Hello children, in the previous video we saw about the terms related to lens, terms related to convex and concave lens. So there were 7 terms and hope you understood them clearly. Now in this page there is something written called first focal point, second focal point, and that's something I wanted to explain, because this convex lens is a bifocal. It's both the sides. It can, so if you have parallel rays coming from here, this side, it can converge them and form a focus here. Okay. On the other hand, even the other way is possible. Suppose if parallel rays are coming from here, if you have the object this side, the rays will meet at a point on this side. This is called first focal point and this is called second focal point. Okay, the one to the right is called second focal point and the one to the left is first focal point. So we will be, in all the ray diagrams, we will not be considering first focal point, we will be only considering second focal point. Now second focal point, and then that leads to second focal plane. The plane passing through the second focal point is called plane, second focal plane, and then the distance between optical center and principal focus, that is focal length. Okay, that is also based on the second focus only. Okay, so it is enough if you study the second focal point for convex separately, concave separately. Okay, it's a point on the principal axis such that the rays of light incident parallel to the principal axis after refraction pass through it. Here, rays of light parallel to the principal axis after refraction appear to be diverging from this point. Okay, so you'll have first focal plane, second focal plane, first focal length, second focal length. Again, we'll be focusing only on second focal plane and second focal length. Okay, now there are few conclusions in this which keeps coming in 2 marks question. Okay, so quickly let's go through them. First one, if a medium on both the sides is same, its first and second focal length are equal. Okay, so if this is 2 centimeter, first focal length will also be 2 centimeter, provided medium on both the sides of lens is same. Second one, usually when we say focus, we mean the second focal point. Third one, now based on this working, we saw that in case of convex lens, the rays actually meet, right? This kind of focus is called real focus. This is called real focus. On the other hand, for a concave lens, what will happen? The rays, you know that the rays are not going to meet because they are going to diverge, and when you extend it backward, they appear to come from a point behind. So this is called virtual focus. So concave lens has a virtual focus, convex lens has a real focus. So convex lens has a real focus and concave lens, the focus is virtual. Now what is real focus? Parallel rays incident on a convex lens after refraction actually pass through this point. Here parallel rays incident on the concave lens after refraction do not actually pass through but appear to diverge from this point. Okay, now this I will be drawing in case 2 that I will explain. Come to the 5th point. Here take down the heading, factors affecting focal length. Factors affecting focal length. The focal length of a lens depends on 2 factors: refractive index of material of the lens relative to the surrounding medium. If a lens is placed in water instead of air, its focal length is going to increase. Second one, radii of curvature of the 2 surfaces. Thicker lens has less focal length, thin lens has more focal length. Okay, thick lens has less focal length than a thin lens of the same material. Another possible 2-mark question is, what will happen if a part of the lens is covered? If we cover a part of the lens, what will happen? Its focal length will remain unchanged, but amount of light entering the lens decreases, due to which intensity of image formed by the lens also decreases. But the position, size and nature of image do not change. Yeah children, this is a convex lens. Okay, I hope you are able to see. The center part will be thick and the sides will be thin. Okay, the center part will be thick and the sides will be thin. Okay, now when you generally it is used as a magnifying glass. Can you see the size of the letters having magnified? Okay, now this is concave lens. Okay, if I touch and see, the center part is thinner, the outside part is thicker. Okay, this part is thinner, so it's curved like this. Okay, whereas this was curved like this. Okay, now in this discussion, in this point that we were discussing, what will happen if the lens is covered? So if I suppose cover a part of the lens, okay, if I cover a part of the lens and only this much part of the lens is there and I'm focusing on an object, now they are asking, will its focal length change? The point is, focal length remains unchanged. Second, only the amount of light entering the lens decreases, due to which intensity of image formed decreases, but the position, size and nature of image do not change, because the amount of light entering will decrease, because I have covered, one part is covered, so the intensity of image formed will be decreased, that's all, but size, position, size and nature will be the same. So these are 2 conclusions that you are supposed to know. Now we go to the B part of this chapter, rules for drawing ray diagram of convex lens. Okay, so like how we had last year, if you remember, concave mirror we used to have 6 diagrams and for convex mirror we used to have 1 diagram. Here it is the opposite. For convex lens we have 6 cases and for concave lens we have 1 diagram. Okay, now to draw those diagrams we need to use some rules or we need to use some principles, so that we are going to see now. Okay, so follow carefully. Rule number 1. Now the first rule says, any ray, optical center F, okay, any ray coming parallel to the principal axis after refraction, it is not reflection, it is refraction. After refraction will go through the focus, principal focus of the lens. Any ray coming parallel to the principal focus after refraction passes through the principal focus. That's rule 1. Now rule 2. Rule 2 is, it's like the converse of this. Okay, means you have an incident ray coming from the principal focus, passing through the principal focus. Okay, an incident ray is coming in such a way that it is passing through the principal focus. It is passing through the principal focus. Now after refraction, this ray will go parallel to the lens. Any ray coming parallel to the principal axis after refraction goes through the principal focus. The second rule, any ray coming through the principal focus after refraction passes through the principal axis, passes parallel to the principal axis. Rule 3 is, any ray passing through optical center goes undeviated. Any ray passing through optical center goes undeviated. So using these 3 rules we will be drawing all the cases of convex, and then for concave I'll tell you later. So these are the rules for drawing the ray diagram. So I told you this as the rule 1, rule 2 and rule 3. Okay, for convex we saw, concave we'll see later. Now we are going to draw the ray diagrams, characteristic and location of images for a convex lens. All the 6 cases of ray diagram for convex lens we are going to draw. Okay, now you are going to draw along with me, and please use scale and pencil. Please use scale and pencil. I am also going to use scale and pencil. So you also please do it and follow the instructions carefully. Follow the instructions carefully. Okay, so you can write the heading as formation of image due to a convex lens. Formation of image by a convex lens or due to convex lens. So the case 1, you will write object at infinity. Object at infinity. Okay, so what we are going to do is, so how to draw the lens? Be very careful. Now sometimes I see children drawing like using a compass or something and drawing such bulging lenses. Don't do that. It should be as thin as possible, then only you will get a proper diagrams. Okay, so what I would prefer is you take 2, 3, 4, 5 lines. Okay, and you first draw a dotted line. Okay. Another thing children, I forgot to tell you, in those rules also, like any ray passing parallel to the principal axis, now usually the bending will happen from the middle part. Like this is the optical center, so you have to put a dotted line along that, and from there only bending will happen, not from here or from here. You should not do the bending from here. No, that is wrong. Also not from this side. No, bending should happen at the middle. Okay, so usually what we'll do is we'll do the dotted line first. That middle part, dotted line you can do first. Okay, then on both the sides you draw this curved part, that is the convex. Is it clear children? This way you get a proper thin lens. Remember that you should have as thin as possible. And I choose 5 lines, 1, 2, 3, 4, 5. That makes it neat and clear. Okay, then we'll draw the principal axis. So this is the optical center, the middle part, geometric, the geometric middle point of this is called geometric center is called the optical center. Now we'll draw the principal axis, a line that is passing through the optical center. Now principal focus, what you do, you mark exactly 2 centimeter on both the sides. Is it clear? So if you want to get proper ray diagrams, you have to follow all these instructions. So this is F and F, and again from this take 2 centimeter and mark 2F, twice the focal length. Okay, 2F. So this will have some significance, I'll tell you later. So from optical center take 2 centimeter, mark F on both the sides, 2 centimeter, again 2 centimeter and mark 2F on both the sides. Okay, now object at infinity. For object at infinity, infinity means some far away distance, like maybe sun. You can take object at infinity, maybe sunlight you can take. Okay, so you can take any number of incident rays. So let's take at least 2 rays. So this is one incident ray and this is another incident ray. So after refraction they will bend, both will pass through the principal focus. So this is the ray diagram for object at infinity. So image will be formed at F, principal focus, image formed at principal focus. Okay, so let's form that principal focus. Now in case 1, there is another position of object, that is object at a far away distance. Object at a far away distance. Now what is the difference between infinity and this? Infinity means very, very far, like sunlight or something which is really far away from us. Okay, object at a far away distance means it's not as far as infinity like a sunlight or something, but you're seeing maybe there is a bus standing at a distance and you're trying to form the image of that. Okay, that is called far away distance. It's little far away from the lens. Okay, little far away from the lens, not so much like infinity. That is the second case that we are going to see. Again, remember, you first draw the center line, okay, dotted line. As I told you, 5 lines you are going to take, and then draw the curved surface on both the sides. That's your convex lens. This makes your convex lens. And then you draw the principal axis, and this is your O. Mark 2 centimeter on both the sides. And F, 2F, F, 2F. Is it clear, children? Now what is the difference between these two? In this, you took parallel rays coming parallel to the principal axis. Parallel rays coming parallel to the principal axis. If it is a far away object, you need to take parallel rays, but they need not be parallel to the principal axis. They need not be parallel to the principal axis. Maybe I can have 2 rays like this. Okay, so any number of rays, they should be parallel to each other but not necessarily parallel to the principal axis. Now what I have to do is, now I can't choose any number of rays. I have to choose those rays with which I can apply the rules that I have got. Okay, so what I'm going to do is, one ray I am passing through the principal optical center. First you draw a ray that is passing through optical center. Okay, you know that a ray passing through optical center will go straight undeviated. Now what you do, from this you take a parallel ray. Keep your scale, move it like this and come till here and draw a ray passing through F. Okay, so draw a parallel ray passing through F. So you move your scale like this till this, and then any ray, this is the rule 2, any ray passing through F after refraction will go parallel to the principal axis. So you will have your refracted ray like this, and so your image will be formed here. Image will be formed here. Generally, image we represent A dash, B dash. AB is the object, A dash, B dash is the image. Is it clear, children? Here it formed exactly at F and everything got diminished to a point, diminished to one point. Here the image is formed on the focal plane. Here we wrote it is formed at F. It is formed on the, here it is formed on the focal plane, and here it is diminished to a point, diminished, or we can say, yeah, diminished to a point, and this one is highly diminished, not to a point, but it is also highly diminished. A bigger object, okay, you focused and got it as such a small image, that is also diminished, highly diminished we can say. Okay, children, so nature, this is the nature of the image or characteristics of image formed. 4 points usually will be there. The first point is about whether the image is real or virtual. This is a real image. Why? The image is formed due to the actual intersection of refracted rays. If an image is formed by the extension of refracted rays, that forms virtual image. Now this is real image, and always real image will be inverted. The real image will be inverted. Then third is about the size, diminished to a point, and fourth, where is it formed? Image formed at F. Here, first point, again real, second inverted, third highly diminished. Here it is diminished to a point, here it is highly diminished, and fourth, it is formed on the focal plane, not on the focal point but on the focal plane. Is it clear, children? So case 1, we had 2 diagrams. Okay, now we go to case 2. In case 2, object beyond 2F. Now I will be doing little fast. Object beyond 2F. In the sense, see, first we had very far away, then we brought it little closer, okay, somewhere far away, but not very far away. Now we are coming much closer to the lens. So object at beyond 2F. So somewhere here, okay, beyond 2F. I always suggest to take an object of size 1 centimeter. Object of size. So this is our object, a line with a arrowhead at the top. This is our object. Now we have to get the image. So from this point, draw the first ray parallel to principal axis. After refraction, passes through the principal focus. Okay. Immediately put the arrow marks. Second ray passing through principal focus, or you can use this or this also, any you can either use the second rule or the third rule. Okay. So I have used the third rule, object passing through optical center. So after refraction, they are, so these 2 refracted rays, the first one here, the second one here, they both met at this point. Okay, wherever they meet, that is where image is formed, and this is A dash and this is B dash. Okay, why? This point, the image of this point is formed here, because the incident rays coming from here, they formed an image here. So the image of this is here. So A here, A dash here, and the image of this will be on the principal axis. So that's why I know I can take that B dash will be on the principal axis. Can you understand how I get an inverted image? Here A is at the top, B is at the bottom. Here it's opposite. A dash is at the bottom and B dash is at the top. Is it clear? Now immediately this is like labeling. You'll write AB object and A dash B dash is the image. And then write the characteristics: real, inverted, then diminished. Okay, diminished means small. Okay, this was diminished to a point. This is extremely diminished. The whole sun could be focused to a single point. Here it is highly diminished. Maybe a big thing had been diminished to this much, whereas here this much object has got little small. It is smaller than its size. See, here you took 1 centimeter, but the image you see, it is 6 or 7 centimeters. So that is why we say diminished image. And where is it formed? Between F and 2F. Between F and 2F. Is it clear, children? So this is the case 2. Now quickly we have to draw. There are 4 more cases. Case 3. Now case 3, object at 2F. Object at 2F. Okay. So take an object of 1 centimeter exactly at 2F. As usual, this is the object A and B. First ray parallel to principal axis. After refraction, passes through principal focus. and second ray passing through optical center and goes straight. Now these two rays meet here and the image is formed here, A dash, B dash. Don't forget to put the arrow marks. Marks will be cut for this. Is it clear, children? Here object was at 2f, image also is at 2f. This is a very unique case. And another thing, object size and image size will be same. Here also it is 1 centimeter and here also it is 1 centimeter. So you have to draw very carefully, otherwise you may not get it at 2f. Okay, so make sure you draw it properly. Make sure you get the image at 2f. Okay, so what are the characteristics? Real, inverted, image will be same size, image is same size, and fourth, formed at 2f. At 2f. So object is also at 2f, image is also at 2f. This is a very unique case and size is the same as that of object. Okay, next, object between f and 2f. Object between f and 2f. Okay, children, we are shifting the object, okay, very far to, we are just getting closer to the lens. So between f and 2f, an object of height 1 centimeter, A, B, first ray parallel to principal axis, after refraction passing through principal focus, second ray passing through optical center, and they will meet here, and so your image is formed here, A dash, B dash. Clear? So see the size now. Image is started increasing in size. Image size is bigger than the object. So real, inverted, and the third one, enlarged. Okay, enlarged means bigger, image is bigger than the object. Where is it formed? Beyond 2f. Beyond 2f. It's beyond 2f. Okay, children. Come to case 5. Object at f. Object at f. We are shifting it towards the lens. So I take a 1 centimeter object towards f. This is my A, this is my B. And first ray parallel to principal axis, after refraction passing through principal focus, second ray passing through optical center. Now if you see these two rays, they will be going parallel. Now will parallel rays meet? No. But I can just say that they will meet at infinity. We don't know where, but we can just assume that they will meet some far away distance. That's called infinity. Okay, so this will also be real, inverted, and highly enlarged. Now this was enlarged, this will be highly enlarged. The image size will be much bigger than the object. Fourth, at infinity. It is formed at infinity. Okay, we can't see it, but we just assume that it's at infinity, and the size will be definitely bigger than the object. Highly enlarged. Okay, children. Now come to the case 6. Case 6 is a little different diagram. Object between F and O. Between F and O. So this is your F, this is your O. So now object is between F and O. So this is your object A, B, and the first ray parallel to principal axis, then passing through principal focus, second ray passing through optical center and going straight. Okay, now if you see these two rays, how are they going? They are going diverged. They are going diverged. That means they are not going to meet this side. Only as I extend them, the distance will only increase. But if I extend it backward, so what you do, you keep your scale and put a dotted line backward. Dotted line backward, here to here and here to here also. Now these two rays will meet at a point. If I extend it backward, they will meet at a point that is somewhere here, and that's where the image is formed, A dash and B dash. And when I write the characteristics, this will be a virtual image. Why? The refracted rays are not meeting, but only by extending it backward they met. So it's a virtual image and it is erect. See, A is at the top, A dash is at the top. So it is erect and then enlarged. Definitely size will be bigger than the object and formed on the same side of the object. Formed on the same side of the object. So object is this side and image is also on the same side. In other cases, it was on the opposite side. I hope these diagrams are clear. So please draw all the 6 diagrams, follow all the instructions, arrow marks, use scale and pencil, and please draw it neatly and send it to me by today. Thank you so much.